What is up, mathletes? Mr. Antonucci here with another video. And in this one, I want to talk about how to integrate f of x equals e to the x, or in other words, anti-differentiate e to the x. Now, in the previous video that I did, I talked about how to differentiate e to the x. And in this one, I want to talk about reversing that process. So if we integrate e to the x, the rule follows right from its derivative. If the derivative of e to the x is itself, the antiderivative is itself, but you have to remember you could have had a plus c there. So just make sure you account for that. Now, there's only so many you could do like this. I mean, you could put a constant in front of it and have 4 times e to the x, and the antiderivative would be 4 times e to the x plus c. What gets fun and interesting is whenever you have a substitution problem involved. So for example, if I had the integral of 4e to the 4x, the exponent is no longer just x. It's its own function. It's 4x. So this would be a candidate for u-substitution. So let u equal 4x, and then du equals 4dx, and we can do the substitution because everything lines up. The u replaces the 4x, and the du is going to replace the 4 and the dx. So your integral would become e to the u du. Everything substitutes nicely. The antiderivative would just be e to the u plus c. And then since the original problem was in terms of x, we want to back substitute what u was in terms of x. It was 4x plus c. And that is our solution there. And you can always check antiderivatives by differentiating. And if you differentiate e to the 4x, it would be 4e to the 4x. And the c would go to 0, of course. Let's do another one. If I had e to the 2x minus 7 dx, I want to antidifferentiate that. So u is 2x minus 7. du is 2 dx, right? But the issue here is that there is no factor of 2 in the integrand there. But since it's a constant, we can adjust for it. For example, if you multiply both sides by a half, you would have half du equals dx, and now we can substitute. Everything lines up. So half in the du, replace the dx, and I could, since that 1/2 is multiplying the du, I can multiply it anywhere in the integral essentially, and so I factored it out front. The u is going to replace the 2x minus 7. Boop, there you go. Now anti-differentiate, you have e to the u, so its antiderivative is just e to the u, but be careful, you have that 1/2 out front, don't forget it, and then plus c. And then since the original problem was given in terms of x, we want to write our answer in terms of x. So 1/2 e to the 2x minus 7 plus c. Make sure you're clearly indicating that the plus c is added on to the end of the function and not just writing it up there by the 7 in the exponent. So be careful with that one. Also, if you check this by differentiating, you would see that 1/2 e to the 2x minus 7, the derivative would be 1/2 times 2, that's the u prime, e to the 2x minus 7, and the 1/2 and 2 would cancel out, and you'd be back to what you started with. Okay, one more. I want to do a definite integral here. So integral from 0 to 1, and I like this one, is e to the negative 3x dx. Again, u substitute here, negative 3x, du is negative 3 dx. Now, there is no negative 3 factor in the integrand because the other negative 3 with the x is taken care of by the u. So if you multiply both sides by negative 1/3, you can get things to line up. So negative 1/3 integral e to the u du. Now, something here that's subtle but important to account for is the fact that I did not write the limits on this integrand because this integral is, or not, I didn't write the limits on the integral in terms of u because the original limits 0 to 1 are in terms of x, and I've switched the variable to be in terms of u. Okay, so don't write the limits unless you change the limits to be in terms of u, which I'm going to do. So if u is negative 3x, right? and x starts at 0, then if I plug 0 in for x, I'm going to get 0. And so that means the lower limit of 0 is going to stay the same. However, if I plug in 1, in terms of x, the upper limit was 1. Since u is -3 times the x value, the upper limit on u is going to end up being -3. Now, I know that the limits flipped essentially, because typically when you write a definite integral, the upper limit is the higher number and the lower limit is the lower number. But don't let that fool you. You don't have to do anything weird with this. Just keep going, okay? So -1/3 e to the u evaluated from 0 to -3. Now, since I changed the limits to be in terms of u, I am not going to back substitute the -3x to get it back in terms of x. If you did that, that'd be okay. Just keep in mind that you wouldn't have to change the limits. If you antidifferentiate and get it in terms of x, then you can use the original limits in terms of x. Okay, just be consistent and don't switch the middle of the problem. Okay, so -1/3 times e to the -3 minus e to the 0. Since both of them would have a -1/3, I just left it factored out. We could clean this up a little bit. You have -1/3 times 1 over e cubed minus 1. And if I distribute the 1/3 through, it's going to change the sign so I can reverse things. So I would have 1/3 minus 1 over 3e cubed. And that is our final solution. You can bust that into the calculator and get the decimal answer if you want to be 0.3167, just so you know. Okay, guys, hope that was helpful to you. Make sure you subscribe to the channel and leave me a comment below if you have a problem that you'd like me to go over. Maybe I'll make a video about it. All right, guys, again, hope that was helpful. Take care.